Hey, how's everyone doing? Good afternoon. Thanks for coming to BWP301. This is how BWP built a resilient multi-tenant SaaS architecture. Before we begin, I'd like to introduce the presenters here. My name is Jiwon Yam, Solutions Architect here in BWP. And before I joined this team, I was also Solutions Architect in AWS. There, I met a lot of SaaS startups, ISV, independent software vendors, and now here in BWP. And today on the stage, I have JD, my amazing co-presenter.
Hey everyone, my name is JD, and thank you for coming to our session. I guess we're cooler than the keynote speaker that's going on right now, huh? Anyways, to give you a quick flash of my career, I have been with Amazon AWS for about 2 years. I started off as an intern, and after spending 60 hours of memorizing the leadership principle, I came to return as a professional service consultant, working as an application developer and an infrastructure architect. I developed and broke many cloud solutions for notable clients such as SAP, Gilead, Expedia, the Navy, and more. I'm now in the buy with Prime space, trying to revolutionize and game change the e-commerce domain. And to the right of me, I have Ryan Lohan, who is one of our brightest principal engineers at Amazon.
Thank you. No, you did the intro.
Yeah, he is the brain behind our architecture, and I urge you to ask all these questions because he'll be there for the last 15 minutes. I bet you $5 you won't be able to crack him, so I'll give it to Ryan to introduce himself.
Thank you. Yeah, I'm Ryan, and I don't think I could top that intro. I'm going to put my pretty face over here. I will be around at the end for Q&A, and if you don't get a chance to ask us questions, see me outside. And I would ask, before you leave, I have one very small favor to ask, but I'll leave it till the end, so stay tuned. Thank you.
Awesome. So since we know who's on the stage, can you show me your hands if you're from developer side? Awesome, awesome. Infrastructure? Cool. PMs? Cool, yeah, there you go. Awesome. And is there anyone have heard about like BWP ever before this session? That makes total sense because we have started like April this year, so our service is 7 months old, and it is in private invite-only mode, so it makes total sense if you haven't heard about it. But we'll get to it very soon. So a little bit about the background of this session. When I look back the days of AWS Solutions Architect, I was lucky enough to go through a SaaS journey with my customers, and I was there helping them out throughout their technical challenges using AWS services. And it was very interesting for me to join BWP because I was able to see how Amazon team is solving exact same problem that my customers used to. And this talk has started from that because after months of observation, this is something we can share to the world and benefit broader technical community and SaaS providers out there. So throughout the whole presentation, we will cover 2 major problems that SaaS providers have to solve. One is identity and isolation, and the second is Noisey Neighbor. So I will first introduce the business problem that we are solving here in BWP and how identity and isolation is built into our system to solve those problems. And JD will come up to the stage and continue with the Noisey Neighbor problems. So throughout the whole 60 minutes of our session, you will get to know how Amazon team uses AWS services to solve the problem that you are having now, and also our core principle, engineering principles and thought process behind it. So let's jump right in. What is the problem that we are solving here in BWP? We started this April invite-only private mode. And what we do basically is extending Prime shopping experience of Amazon.com. So you do not have to be Amazon seller to provide 2-day free shipping, easy checkout, painless return process that millions love and trust already. So what happens is you can stay where you are as in your website, and you can insert one button saying BWP. And now you're able to invite the Prime benefits to your customers. So there are currently 2 ways to interpret our system. And one is the button that I just discussed. And if you decide to do so, what happens is we create the code snippet for you, and you insert the snippet into your website, and you're off to go. But if you're tech savvy and have some custom integration that you want to build with us, you can do so using our APIs. And coming very soon, we're going to have developer tools to make our developers' life easier. And if you're interested, please stay till the end of the presentation. You'll get to know the channels, how you get the updates. Enough about BWP Prime definitions. I'd like to introduce who we have here as the user personas. We have some key stakeholders, right? Front and center, we have the merchants, and they own their retail business, and they now want to expand it even further using BWP Prime. To do so, they have to please their customers, who are the shoppers. They love shopping at Amazon.com because of its 2-day free shipping and all different Prime benefits that we have. And they are now even happier because they can take advantage of the same experience from their favorite brands, even when they are not on Amazon.com. But when you build the service that your shoppers love, you need more than one website to make that business happen. You need the whole village for that. So we work with BWP Prime partners to create that ecosystem for our merchants. We as a team, BWP Prime partners and us create tools, assets, services for our merchants, and we try our best to create the best business operation opportunities and experience for our customers. And when you think of marrying your business to another party, considering the shoppers are not directly systemically integrating with us, we have the merchants and partners who are directly calling our systems, right? They have key concerns, and as a service provider, we want to solve that. So I'd like to visit the most common concerns here. As a merchant, when you think of the IT side, the data protection should come high priority. Let's say they are storing some card payment information, and somehow, let's say, it got leaked. No one wants that, right? That is a simple nightmare for everyone. And as a merchant, you do not want your promotional plans, inventory stocks known by your competitors. So you have to protect your business confidential information as well. For the partner side, they have similar, slightly different concerns. As a service provider, they are serving multiple customers, just like we do. And we do not want any uninvited security breaches happen from our new interfaces to another softwares, right? And it makes sense if our partners are worried about those situations all the time. It makes sense. And they are also very sensitive about the availabilities. They should be aware their service should be 24/7 up and running. But let's say some newly connected system has Noisey Neighbor issues, and it kind of breaks down their system. That is not cool, right? So as a service provider, we want to solve that. Yeah. But that's not the end. As SaaS providers, we have our own internal challenges as well. On top of those business problems that we are solving, we have to be absolutely cautious about the security. And all the things we have just discussed can boil down into the security and reliability. And this is something we never want to miss at any circumstances. And we should also value scalability in our system too, right? Because in our case, we want to invite as many merchants as possible because they are our customers. And I believe you should feel the same way. And we want to serve Black Friday scale traffic for our merchants. And you should have some business objective for your customers as well. So we should have scalability built into our system. We also value flexibility. Even though we are Amazon, our service is like 7 months old. And we want to explore as diverse opportunities as possible. And that is not possible once our system is not flexible. So we should have that. Lastly, we should definitely have some cost efficiency in our system too, right? We do not want to waste any resources for unnecessary heavy lifting. And we would rather use that resource to actually create something beneficial, something innovative for our customers. To solve all those business problems and these internal challenges that we have here, I would go through the architecture overview that we landed as a team in BioPrime, and how building identity and isolation into that system plays a key role. We should definitely jump into those architectures. I will start from 50,000 feet. Here, we'll see the big categorization of the architecture, and we'll be able to see what was our philosophy behind it. And we will zoom in until we hit 10,000, and there you can see actual software design components to AWS services and how our philosophy connected to whole AWS services. So let's start from 50,000. We have merchants and partners on your left side of the presentation. They are main user personas. And since we do not know what our customers love about us yet, we want to explore how people like us, what people love about us, and what people do not. And to make that happen, we broke our architecture into two big parts: customer-facing layer, which are the products like buttons, APIs, the developer tools that you saw as the ways to interact with our system. So basically, the merchants and partners choose their way to interact with our system. But the actual logic lies in backend services. So when you think of the commerce industry, to complete one transaction, we have to have multiple subdomains. This includes payment, orders, catalog, delivery, you name it. And many more services should work together to complete that transaction. So basically, wherever the request comes from, the same set of microservices in the backend work together collectively to deliver the answers. By doing so, what we accomplish here is bringing the flexibility into our system. So our product team has the freedom to experiment with their product customer-facing layer and experiment as much as they can without downstream dependencies to backend services. And at the same time, the backend services can add their own foundational features to themselves. It might sound pretty straightforward. Backend service and front-end service, there has been forever. But when you think of this as product, and ask yourself the situation where your product manager comes to you and asks, hey, we are trying to build this cool new, totally never been existed customer interface using our existing system. What should we do? Your answers might not be straightforward. And we do not want us to be in that situation too. We wanted to have flexibility in our DNA to start with. So by decomposing all these backend services from customer-facing product layer, we can have that flexibility. But remember the first challenge that we came up as that we had was the security and reliability. And if you're a tech person in a SaaS provider or multi-tenant architecture team, probably the first technical question you'll be asked will be your tenancy model. Do you want your tenants to share resources? If so, like how? Account level, VPC, or what? And we had to answer those same questions too. Before I jump into what BioPrime did, I'd like to visit the most common two ways to deal with this multi-tenancy. One is the siloed architecture, right? Where the tenants do not share resources. They have their own siloed resource for themselves. And that is great because it is convenient to have some boundaries between the resources. But that comes with a lot of cost in the sense of price and also your operation burden. So in the other hand, we have pooled architecture where you have your tenants share resources. And that is great because it is cost efficient, both in price and maintenance effort. But you have to be very strategic about putting isolation boundaries between your tenants. And we did the same thing too. But when I recall my old days as AWS SA, the most common people can fall into is they feel like they have to decide the tenancy model from the beginning about all the workloads they have and stick to it as long as they can. But that is not necessarily true because that's only possible when we analyze our workloads deeply and understand how our traffic works and what the characteristics of data to be stored has. Because of that, here in BioPrime, we let each microservice team to come up with their own multi-tenancy model and ways to implement this. We went through a lot of architecture design discussions and went through a lot of thorough reviews with principal engineer like Ryan. We ended up having a lot of pooled architecture for ourselves. But when we do that, we have to be very careful about the isolation boundaries, right? So we came up with our organization-wide multi-tenancy guideline and best practices within our team using those principal engineer-led multi-tenancy guideline and also some from AWS Red Architecture Framework. So we are now in 20,000 feet, and here you'll be able to see the high-level design of our architecture. Quick flashback about 5 minutes ago, customer-facing layer, and we had backend services. And they had two different functional purposes. Customer-facing layer they just interact with our customers, merchant and partners. So what that means in technical term, they are just gates, only interface. So they do not store any data. So what we want at this layer is straightforward. We want two things. We want them to have very highly available performant front door. And two, securely hand over the request after validating if that caller has rigid permission to make the call. So we go through token validation really hard, sorting policy, and all different conditions to hand over the request to backend service where actual important data, business logic and data lies. So in backend service, we didn't have too much of isolation in customer-facing layer because simply we do not store any data there. But backend service has different story. So what we do here is decomposing the management layer, also the data logic layer, and actual data storage. So we first go through the control plane logic, where we have metadata management, including searching for tenant-specific resources, such as table, encryption key, and all different things that we create on behalf of the tenant. And then we go through the sorter check again at that specific microservice layer, then finally runs the business logic in data plane, and if necessary, we go to data storage to complete the transaction. Having these multiple layers in backend services, what we accomplish here is giving us some room to put multiple security and control measures to make sure we have right isolation boundaries for tenants. Now we are at 10,000, where we can see the mapping of those software components that I have just discussed to AWS services. This is not necessarily rocket science, but we do have a couple of principles that we are following across the organization. I'll not introduce what is API gateway and such, but I'd like to give you three main learning points here. First thing that you can notice from the big picture is that we have logical unit of compute account and data account. We do serve multiple merchants and partners from one AWS account, but we decided to have this logical unit. This serves two main purposes. One is we do not want to cascade any security breaches, availability issues down to data where the actual important, valuable information lies. And secondly, we as SaaS providers, our maintenance is also included in our service. And to make the top-notch level of our operation, we wanted to keep our staffs least privileged at all times. And if we separate the AWS accounts, we have another mean to isolate the staffs and make sure only necessary people access necessary data storages. And the second thing that you can notice from here is that we are encrypting the data end-to-end. Even though we have lots of internal communications, we do not want the data decrypted and just hanging out outside. So what you can notice from here is we have NLB as a target of API gateway. And the main reason was we did not want to terminate the encryption at load balancer layer, but we would rather just bring the traffic encrypted through API gateway and pass through the NLB and reach the ECS container where actual logic happens. So by doing it, let's say somehow our traffic is hijacked somewhere. The hackers cannot know anything because they cannot decrypt the data. So that was the second point of our architecture here. The last thing is isolation at rest. On your right side of slide, we have tenant-aware silo tables. And we do that for major data objects. And that is awesome, because we can use AWS native technologies such as IAM policy to make sure we have right access control. But as you already know, having silo table can be challenging sometimes. And we do have some shared table by ourselves too. Sometimes we store data in shared table, and we do not want the security bar to go lower in those cases. Even though we share the tables, we want to have the same security bar for ourselves. So to do that, we use the KMS encryption key dedicated for the tenant. So let's say I'm G1 trying to store the data in the shared table. What happens is we bring tenant-specific encryption key that is assigned to me, and I can only access that encryption key. So before I store any data, the data is encrypted before storing, and it just stays there encrypted. And let's say JD came and tried to hijack my data in the table. That can happen because he does not have access to my encryption key or decryption key pair. By doing it, we could keep the same security bar even though we are sharing the physical tables. And this is great. We have our very thought out architecture of our own. But the thing is, we have so many microservices of those because we have lots of order, catalog, and different domain services, right? So to make sure we have this isolation-enabled architecture woven into one full shape, we have to also be very strategic about our onboarding process. We have many, many different layers in our architecture, and we want to make sure that we are doing the same for every single one of the tenants. So what happens is when the merchants come our site and sign up, the first thing that we do is creating the tenant ID. And this should not be new to you. You should be already doing it if you have the multi-tenant architecture. We have the tenant ID created, and if that happens, then we trigger the merchant-specific resource creation process, which is implemented by CloudFormation. So the created tenant ID handed down as a parameter throughout the stack, and the underlying resources consume the ID as a label for themselves. When you squint your eyes a little and look into this template, you can see we are creating instance for that specific microservice. What that means is, since we have some AWS services created for the tenant, like encryption key, and we do sometimes have our own database to check those resources. So we have to run not only creating AWS resources, but have to go through the control plane registration logic. To make those things, two things happen at the same time, we we use the private resource type to implement this. So after going through this process of creating tenant-specific resource creation process, now each backend services know which resource belongs to who and which resource is created at what time. With that information, the users, our merchants and partners, can now finally access the resources. And let's put our final piece of identity and isolation strategy by learning how the tenants can access them. And to do so, we have to understand our identity service. This identity service is nothing more than a wrapper of the identity provider. And it sits between the user interface and IAM/SDS. And I will walk you through this process with an example, me as a merchant trying to access the list of our orders. Let's say I have socks store, and I want to see the whole list that happened throughout the whole year. What I need to do to make that happen is I go into Merchant Console and I sign in, and if everything checks out on behalf of me, this will call the identity service say, hey, give me some credentials. And this user is G1 and her tenant ID is this. And I'll say this is the single most important step to build secure SaaS architecture. You should make your tenants carry tenant ID at all times, under any circumstances. This is the single most important step. And if the identity service takes a request and everything works fine, it goes to IAM/SDS to create a assume role session where I, as a G1, I can only access resources when the resources are labeled as mine. I cannot access GDs or Ryans because I do not have the permission to do so. So we create the credential, which is very tenant-aware, scope-down, temporary credential. And with that key, behind the scene, we call the backend services that we have just discussed so far, very isolation-enabled, identity-aware. And they go check their IAM policy and control plane databases using the given tenant ID in the resource context. And if that checks out with their policy, I finally can see the list of the orders. And that is how we weave all the things into one picture. And this is not the end. Sorry. We want to make sure 1,000% we are isolating the data as we plan. And sometimes people forget to run test cases dedicated for multi-tenancy. And we did not want to do that. We brought the specific dedicated cases for our tenancy model. So those are running at every single deployment phases we have. This includes positive cases for sure. And those should have also key failure cases where the requests fail even when they have admin access and they are not from the allowed list that we have. We just want them to fail. They are not allowed in AWS account. The next key part is we do not want any request to succeed if they have wrong tenant ID, even when they are from the right AWS account. And I'll say these are something people usually miss, and if you are not already doing it, I highly recommend you to bring these cases back to your office and make sure those are included in your test cases. By running all these test cases, we now confidently say that we have very firm identity solution. And having those not only solves the security and reliability issues that I have covered so far, it also helps the noisy problem that JD will come up to the stage and introduce to you. Take it away.
Awesome. Good job. Sweet. That was awesome, Jiwon. What a great explanation of our very own architecture. I hope everyone had learned something from there. So in my segment, I'll introduce this notion of noisy neighbors and share some of our best practices in solving that case. So the idea behind Noisey Neighbors is that a tenant could place a heavy load on a shared resource, which might have an adverse effect to the resource itself and for other tenants living in that system. Now, this could be bad, really bad, because this degrades the experience of tenants living in that system, but it also abuses our very own system. Though let me just backtrack, because it's not always a tenant that could place a heavy load or abuse the system, though it could be really any actors or entities interacting with that system, which might include our very own teams. So that said, let me take you through some of our best practices and mechanisms in solving this case. And how do we actually solve this case? Well, first, we'll deep dive into our very own prevention strategies. Here, we'll explore what it takes to prevent a noisy neighbor from abusing our systems and also share some of our defense strategies in limiting that noisy neighbor as much as we can. Then, in the latter, we'll explore what it takes to monitor our systems, our APIs, our tenants, and importantly, how we detect noisy neighbors. Because let's say a noisy neighbor does creep in. How can we quickly identify that noisy neighbor and take action? So a lot of variety here, a lot to cover. Let's dive right in. So preventing noisy neighbors, let's go. Now, before we begin, let's quickly refresh what throttling is. Throttling is a technique for preventing one workload from starving a service of resources that it needs to serve for other workloads. Throttling lets you define a quota for each workload. So requests above that quota are simply replied with an error message. In this case, it gets throttled. So because our architecture is because our architecture is hosted in a multi-tenant pattern, noisy neighbor issues can happen without proper rate limiting mechanisms. And because our architecture is heavily based on microservices, throttling happens and should happen not just at the front door, but at every application level. And as Jiwon explained, because our architecture consists of many application layers, throttling should happen in all layers, in the API layer, in the application layer, and even downstreaming to our dependent resource. So if there's two things I want you to take away from this slide. One, tenants are not always well behaved, intentionally or unintentionally. So the act of returning an error response should be inexpensive for your services as much as possible. And two, throttle for downstream resource protection. Imagine if you had auto-scaling configured on your instances without any throttle enforcement. Now imagine if a user sends 1 million requests to that instance. For one, your instance will be overloaded. Two, your bill is going to be massively enormous. And three, the CFO is going to come knocking on your door, and you're going to have to explain why you didn't listen to Jiwon and I's presentation. And that's not what we want. All right, so now that we covered some ground, let's talk about what happens at our API level. At a high level, requests are first screened by a web application firewall. If the request passes, it then gets directed to an API gateway, and then to our backend services, depending on the type of request. Now, hold up. We can't just let any amount of requests through. See, we have two throttling measures featured in these two services, one in the WAF and one at our API gateway. So let's rewind back at our WAF. See, the WAF has a neat feature called a rate-based rule in which supports our throttling measures. In essence, we can configure a rate of requests for each originating IP address and then apply a set of actions for rates that go over that request. Now, officially, once the request passes through the WAF with our rate-based rule, it then hits our API gateways. And because our API gateways are married to our backend services, we leverage what's called an API gateway usage plan. Now, API gateway has this custom notion of an authorizer. So every request that comes into the endpoint, we pretty much inspect it, we get the contents based on the tenant ID, and then that will affect the flow of the request, whether that's allowing the request to go through, deny it, or even throttle it. So during this authorization period, a Lambda is running behind the scenes, and it processes this request. And through written logic, we grab the tenant ID stored in the Dynamo database and then map it to a usage plan. Now, this plan is our bread and butter because in this plan, we define the burst rate, set a quota, and define other variables in this policy. So those are the two things that are happening in the front door. Now that we have a front door shield, let's segue into our application level. At a high level, here is a user calling a get order detail request. Now, this request will involve 3 backend services: order, catalog, and payment. So the request will first hit order to get the order ID, and then it'll go to catalog to get the product details, and then so on and so forth. So where does the throttling actually happen? Well, it happens at every backend service. See, the resource context passes the tenant ID into each one of these services, and then the request will go through some sort of throttling engine before going to the service. So starting from the top, order service will validate that tenant ID, and then it would go through some throttling engine before going to the service, and then once it passes, it'll go down to catalog, so on and so forth. Now, once the user sends this get order detail request through our full API chain, users will get their appropriate response. Though, what is this throttling engine that is happening behind the scenes? What is this throttling engine that is happening at the application level? Well, here in BWP Prime, we widely use this internal throttling service. And just to call out, although this is a popular throttling option here in BWP Prime, we do leverage other options based on what's best for our teams and for the service. So sitting on top of the service, the request will first go through what's called a service handler. Now, the service handler will intake this request and pass this information to a throttling engine. The throttling engine will parse through this information told by the service handler, and then it'll run through this tool called a capacity descriptor. Now, this capacity descriptor is pretty much the brain in the logic because the capacity descriptor can request capacity on the targeted service. It also can identify the weight of the request, can see the tenant of the request, and also rank the request as well. So think of the capacity descriptor as like a bouncer in the club. And then the throttling engine is like a club owner. So the capacity descriptor will report back to the throttling engine, and then the throttling engine will make its throttling decision based on the information told by the capacity descriptor. So depending on your vibe, you either get into the club or you're going back home. Now, if you pass the vibe check, your request will go through, and then you'll get your response. All right, so that wraps up prevention in a noisy neighbor context. And I'm going to switch gears into how we monitor our systems, how we monitor our APIs, our tenants, but importantly, how we detect noisy neighbors. And you all probably know why it's important to have visibility into tracking your systems, but how do we actually do that here in BWP Prime? Well, in BWP Prime, we collect many, wait, did I say many already? Not enough? Okay, many metrics that are streamlined to dashboards, to logs, to insights, and more. And by doing this, we can see it from all angles so that we can understand how our systems are behaving. In essence, we can see who's making the noise, and then we can take action. All right, so what are some of the tools and services we use to detect that noise? Well, because our services are mainly built through AWS, we leverage all CloudWatch things because it's easy to integrate. So starting off with dashboards, we use dashboards as one mechanism to address the challenge of staying on top of activity, and we have a lot of them. From high-level dashboards to system-level dashboards, you name it, we got it. We can find that needle in the haystack. We also configure a lot of metrics. We can see activity from tenant ID to account ID, even through a service. We then integrate these metrics into CloudWatch alarms so that we can quickly be notified about noisy neighbor issues. We also collect a lot of logs, and we analyze them, from tracing API calls to even operation errors. We then power these logs with log insights so that we can better search our log data even better. And lastly, this last tool listed in this slide is something that we uniquely built. It's our Buy with Prime CloudWatch Logs CLI. Inspired by the existing CloudWatch Logs CLI that is publicly available, we further developed this, we further advanced this, so that we can quickly retrieve logs and to help for our other use cases. So we'll go more about this one a little later, so stay put. All right, so here is an account level dashboard, as I spoke about dashboards earlier. From this angle, we can look at all of our accounts activity in a single pane view. Now, if you squint your eyes, maybe wipe your glasses, you can see that a particular account is having issues. Here, let me help you out. So you can see this account is having a lot of errors on the get category API call. Now this is very funky, very interesting. Let's further investigate. All right, now we switch on to CloudWatch Log portals. Here I'll run a query to understand what tenant is calling that API and also what is happening with the response time for that API. Now, what's really cool about CloudWatch Logs, CloudWatch Logs, is that you can query on specific filters, metrics, and a lot of other things. So very neat and powerful tool I highly recommend. Now, let's get a little more granular. All right, here I'll do more specific queries to answer the impact. On the left there, we can get pretty much the customer impact list based for that specific API call. And on the right there, we can get the latency impact for all customers impacted based on that API call as well. So through investigation, we figured out who that noisy neighbor is. We looked at all of the customer impacts, and now we can take action, then better position ourselves so this won't happen again. Though this process, it's a little tedious to go through all of these portals, links, write intensive queries. So back to it, introducing our Buy with Prime CloudWatch Logs CLI. We built an advanced CloudWatch CLI so that we can better analyze and quickly retrieve our log data. So sharing a few benefits of this CloudWatch Log CLI that we built, we can get the full context of a request without clicking through different links, accounts, etc. It helps us cut down the time to find the logs that we need, typically in 1 minute. And then we can easily pipe different queries together to search across different log groups and more. So here is an example of the tool running on the terminal. And with this powerful command, we can essentially get all of the top 10 merchants and customers impacted based on that specific API call. We can also do further investigation and write and include more commands to look at the account, the service, and other things. So that wraps up Noisey Neighbors and everything about it. Now, for those who might be sleeping or for those who's on the phones, this is the time that you should be listening because we're going to go over our key takeaways. So feel free to pull up your phones now and take a picture because essentially we condensed our material for you so that you can start enhancing and building your SaaS architecture. And I'll have Jiwon come back on the stage so she can do the first half of the key takeaways and then I'll finish the remaining.
Yeah, the first thing that we have learned here was let your resource know who the owner is. Your resources, if you create some for them, they have to know the resources by themselves, who their owner is, so that you can have some flexibility in your system. And that connects to the second point of our key takeaway. By letting your resources know the owner, now we can use that tenant ID to isolate the tenants, 1, 2, and use that information to effectively tackle noisy neighbor problem. And lastly, we talked about the test cases for multi-tenancy. We do miss sometimes, but don't forget we have to have some dedicated test cases specifically for the tenancy if you are a SaaS provider or looking for very secure SaaS architecture for your own.
All right, last two there. Fourth one, to contain noisy neighbors' impact, your architecture should throttle at multiple layers. By doing this, you'll have a lot more depth of defense and protect your applications. Lastly, use telemetry to identify noisy neighbors. Like I said, it's important to have a lot of these dashboards, logs for you to analyze so that you can see how your systems are behaving. So I think we've been talking a little too much, and that coincidentally wraps up our presentation, but I have a couple of requests for you. So first one, you can learn more about our Buy with Prime in the AWS demo theater. Here we'll be featuring our products live, so feel free to check that out if you're not hungover. Also, scan the QR code to the left there on my left-hand side so that you can get future news, updates about our products, our visions, a lot of our open source toolings that's in the pipeline, so really cool there. Lastly, I have a favor for you, and this would mean a lot to me if we can all contribute. Today is my co-presenter's birthday, and she is amazing.
Thank you.
One last request, sorry. It would mean a lot to me if we can all say happy birthday G1 on 3. Can we all do that? Yeah. All right, 3, 2, 1. Happy birthday G1.
Oh, thank
all
you.
Right. Thank you all, thank you.